In this video, we'll have a quick look at some of the more common problem-solving questions that come up in the biology papers. Okay. When preparing for the assessment, it's a good idea to start getting yourself familiar with the language and the wording of the SQA questions. And a good place to start is by making sure you know all of the different command words. It might be a good idea to pause the video, have a look through, and make sure you're familiar with these different terms. We'll mostly focus on the different skills that come up all the time in problem solving, such as predictions, selecting information from graphs and data tables, some of the common calculations, and conclusions and analyses that you can make. So one of the more common types are your predict type questions, where you're asked to predict the next value in a particular pattern. So let's try by using a past paper question. So we've got a data table that shows us the length of UV exposure time in minutes compared to the number of yeast cell colonies alive at each time point. And the question was to predict the number of yeast cell colonies that would be present if the exposure time was 11 minutes. So we can see from the data table that we're recording the number of yeast cell colonies every 2 minutes. So what would be the next number in this pattern? So we have to establish the pattern that already exists, i.e. the difference between these values. Okay. So the difference between 1 to 3 and then 3 to 5 is difference of 4, then 8, then it goes down by 12, and the 7 to 9 minutes it goes down by 16. So our pattern is the 4 times table. So we need to follow that logically on to the next time point. So what should be up next in that pattern is 20. So we're going to 30 minus 20 for our final answer of 10 yeast cell colonies. Another common calculation that comes up is percentage change, which tracks how something changes over a period of time. So there's 3 steps to doing this calculation. First is to find your difference between your two values, your start and your end. Then to divide that difference by your starting value, and finally to convert it into a percentage to multiply by 100. So in this past paper question, we know that there were 500 deaths from ovarian cancer in 2007. That's your starting value. And also from the data table, we know our final value is 400. So we want to know the percentage decrease between these two time points. So step 1, find the difference between your starting and end value. So 500 minus 400 for 100. Step 2, divide that difference by your original value, which was 500. And that worked out as 0.2. Finally, multiply 100 for 20%, decrease in the number of ovarian cancer deaths. You may be also asked to do a ratio, which is the comparison of two values, and you'll always be asked to express it in its simplest whole number form. So you'll never be dealing with decimal points. For example, a ratio of 50-50 will always be simplified down to 1 to 1. So the way to do this mathematically is to find the largest number each side has in common that can be evenly divided by, divide both by this value. Kind of cheat way, if you like, of doing it. If it's an even number, start dividing by 2. An odd number, start dividing by 3 or maybe 5, and you should still get to the same point. So again, let's look at this past paper question. So you were to express as a simple whole number ratio the number of excess winter deaths in Scotland compared to those in England in the year 2014-2015. So you're pulling your data from the graph and then simplifying the ratio. So we're looking first at the number of excess deaths in Scotland. Values are on the left hand side. And then for the number of excess deaths in England, which is shown on this right hand side, the key also shows us that the white boxes are the English values and the black boxes are the Scottish values. So it might be a little difficult to see on your screen, but the first thing you need to do is to pull out the data from the year specified 2014-15. So it must be in the order the ratio is presented. So for Scotland, it works out, we read it off the graph as 36. Remember, England, you're reading from the right hand side, it's the white box, which is sitting at 400. So that's your initial ratio that you then need to simplify down. Both those numbers will divide evenly by 4 to give you a ratio of 9 to 100. Again, you could have divided by 2 and just done the calculation twice. Graph work is going to be important as well. So let's make sure we can work with these line graphs. So we've got information from the question that the graph shows a patient's white blood cell count and the chance of infection following chemotherapy. So again, start by familiarising yourself with the key. The solid line is the white blood cell count and the dotted line is your chance of infection. Question 1, state the chance of infection after treatment when the white blood cell count was 0.7. So the white blood cell count is on the left hand side, so we need to find our 0.7 line, go along to where we find the white blood cell count. So we're comparing that then to the chance of infection. So to see where these two lines meet, we go down. Okay? A lot of students will go side to side, but that's incorrect. You're always going up or down to see where the two values align. Okay? So when the white blood cell count is at 0.7, the chance of infection is at 15%. Okay, so that's your final answer. You may also be asked to do a prediction question using a graph. So predict the white blood cell count 7 days following chemotherapy. You see the line stops at day 6. So to find what it should be at day 7, what you do is you get your ruler, you align it with the white blood cell count, and you continue that line along its current trajectory, which shows you at day 7 the white blood cell count would be at 0.1. You may also have a bar graph, so again it's important to be able to work with these types of graphs, pull out different information. So in this one you're being asked to make conclusions. So the only way to do that is to test each of those different options and see which is correct. Okay? So try this one, you've got your key, the lighter grey is your slow twitch, the darker grey is the fast twitch, and you're comparing the percentage of each muscle fibre at the different distances. Okay. So test out these different theories. The only one that will hold true is D. So athletes who train for the 100 metre event have twice as many fast twitch as athletes in the 800 metre event. Okay. So it could be a case of going through, pulling out the values and doing the calculations. So hope that gave you a brief overview, some more information on the different problem solving questions that come up most often. And please do let me know if you still have any questions or anything that needs clarified.